Okay, now we'll talk about something called the center of mass of a system. Okay, so here's an important concept. So you guys remember that when you throw an object in a gravitational field, in a constant gravitational field, the path is a parabolic path. It goes on when you toss a ball, it goes on a parabolic path. Now let's toss a baseball bat, and you see this, the handle of the baseball bat doesn't go on a parabolic path. The head doesn't go on a parabolic path. It turns out that only one point on this baseball bat goes on a parabolic path. And that point is the center of mass of the baseball bat. And that's the center of mass of the baseball bat. So for instance, if you did a flip, only your center of mass will go in a parabolic path. Your hands, legs, and stuff will not go on a parabolic path. Okay. So now the question is, how do we find the center of mass of an object? Your center of mass is sort of roughly behind your belly button. Okay. So how do you find the center of mass of an object? Again, I urge you guys to go to these two links and you can see the center of mass of various objects. Okay. All right, so for instance, if you wanted to find the center of mass of an object such as this, just suspend the object from this point, and the center of mass is somewhere on this line. And then what you do is suspend it from another point, and the center of mass has to be on this line. And the intersection of the two lines will give you the center of mass. So that's how you can find the center of mass of any object. Now, for a three-dimensional object, you would have to suspend it from 3 points and would need the intersection of 3 lines. But anyway, so that's how you find the center of mass of the object. Okay. Now, what this is showing you is, for these 3 particles, the center of mass is there. So the center of mass of an object, of a system, can, it doesn't have to be inside an object. It can be outside. That's the center of mass. Okay. And here's how you find the center of mass of, here's how you find the x coordinate of this, the center of mass. The x coordinate of the center of mass is each particle times its x coordinate, each particle times its x coordinate, divided by the total mass. And the y coordinate of the center of mass is each sum over each particle times its y coordinate divided by the total mass. So that's what these formulas show you, how to calculate the x, y, z coordinate of the center of mass of this object. Again, the important thing to notice, the center of mass of an object can be outside the object. Okay, this slide shows you how to calculate the center of mass of a continuous object. So the center of mass of this object is that, and the x, y, z coordinates of this point are given by this formula. These are triple integrals that one would have to do, but this information is useful enough where you have tables for the center of mass of various objects. Okay. I mean, oftentimes we don't do these integrals. Anyway. All right, so here's an interesting thing. So this thing is called the Fosbury flop. And I believe he was a Norwegian. He invented this flop somewhere in the late 60s. And the idea is as follows. Before the 60s, before this flop was invented, most people would go over a bar like so. And this is the Fosbury flop. Now all athletes go over the bar like this. Okay. So what is the advantage of this compared to that? Okay. So let me show you what the advantage of this is compared to that. Okay, the advantage of this is, well, okay, so let me go to a whiteboard. Okay. Now, So here's a side view. This is the ground, this is the bar. Now most athletes roughly have the same amount of strength. So they come up, they jump, and if you did it the old way, if you went like that, so what essentially you're doing is there's your center of mass, and you raised your center of mass that much, and the work you had to do was this much, mgh. H is that height. So there's the bar. And again, like I said, most athletes can just about do the same amount of work. And now, if you learn the Fosbury flop, okay, so if you learn to fold your body over the bar, like that, now your center of mass is over here, and you didn't have to do as much work, okay? So since you can lift your center of mass there, now in that situation, so this person, instead of jumping like this, if he had jumped like this, so he can raise his center of mass that far, he could clear a bar this high. Okay, I hope you guys understand that, what I'm trying to say. So now, learning the Fosbury flop, instead of being able to jump a bar this high, now you can jump a bar this high. Okay. Anyway, so that's the advantage. So in the Fosbury flop, what this diagram is showing you is your center of mass is actually going underneath the bar, and you're clearing a higher bar. So for less work, you got more results. Anyway, so when Mr. Fosbury first tried this out in the Olympics in 1968, he beat the pants off of everybody. Everybody else was jumping like this, and Mr. Fosbury jumped like that, and he won by a large margin. Okay. All right, let me pause here a second again.